Okay, we're going to be practicing piecewise functions, but at the same time, this does a quick Math 1 review about features of functions on each graph as well. So notice right here where it says function, this is where you're going to write the three-piece piecewise function, but over here, domain, range, min, max, all of that is a review of Math 1. Notice that on accident here, it says increasing, increasing. It's supposed to be increasing and decreasing interval. I hope you noticed that typo and made the adjustment. How do we write the notation for the features? Remember, we're going to use interval notation for the features from Math 1 and set notation for the piecewise. Okay, here we go. Point slope form of a linear, in case you need to have this handy. Slope x minus x1 plus y1, the same format we've been using for the last 2 weeks. And then notice the similarity to vertex form of a parabola, where we go stretch x minus h plus k. So the critical point of a quadratic is your vertex, the hk. The critical point of a linear function is any x1, y1. Okay, so using those as a oh, what did I forget? The most important part. That one is squared. Okay, let's put that squared back on there. So how do I tell something's linear? No squared. How do I tell something's quadratic? Squared. Okay, looking at the first piece, the domain is broken into a couple sections. For example, as I'm traveling along the x-axis, I'm noticing that it's going like this, like this, like this, like this, like this, stop. But then it jumps at the same point, starts up again, continues on the domain. So we're going to say that even though there's a jump or a gap in between these two pieces here, that there is a continuous domain from here to here. So let's go negative 1, 2, 3, 4, 5. This is going to go from negative 5 all the way to 2. But then there's a big jump in between that third and final piece. So we're going to go U for union. And this one goes from 3 to infinity. Now, what kind of brackets are going to go on this interval notation? Notice the parabola starts with an open dot. So we're going to put an open bracket. Notice over here at the end of this domain, it's a closed dot at 2. So we're going to put a closed bracket. Down here, this starts with an closed dot at the domain of 3. And this is to infinity, which is always an open bracket. If it's confusing to you, this 3 to infinity, why is that a 3? Like, where is the 3 coming from? The coordinate of this point is out 3 and down 9. Domain is the x value. So you're going to use the 3 to infinity, nothing to do with the negative 9. That's going to come in later when we're doing the range. Okay, so there's your domain. Even though it's 3 pieces of a piecewise function, and later we're going to do each piece and each domain for that piece, when you do the overall domain of the graph, we've got a continuous domain jumping from the parabola to that line segment. So I know that can be a little confusing, but here is the domain in only 2 pieces. The U in the middle stands for union. Now range is going to be the y values. We're going to look at the lowest point of the graph, which is down here at negative 9, to the highest point of the graph, which some people think is right here. That's a relative maximum, but check this out. This is an arrow to infinity, so it actually trumps that other highest value. So we're actually going to say from 9 to infinity is our range. Now, what kind of brackets should be on that interval notation? This is a closed dot here at the bottom, so you're going to go negative 9 closed. Infinity is always open. How'd you do on that range? The increasing intervals, at what sections of the graph is the graph going up? So from here to here, that's going to be on an interval, back 1, 2, 3, 4, from negative 4 to negative 2. And then there's also a section increasing right here, that's from 3 to infinity. Whenever I'm doing increasing, we're talking about something that's happening between 2 dots. So we always use open brackets on all increasing and decreasing intervals. It's what's happening in between 2 spots. The decreasing sections of this graph are going to be this part over here. this little tiny downwards part. So that's going to be from negative 1, 2, 3, 4, 5. Negative 5 to negative 4. Increasing and decreasing are all open. And then there's another decreasing section from negative 2 to 2. Increasing, decreasing, and domain, I'm going to highlight those, all use the x values of your graphs. Range, min, and max all use the y values. Y-intercept uses the y values. X-intercepts uses the x values. You can feel free to highlight those coordinating colors to know which ones use x and which ones use y. All right, the minimum value of our graph, we already got that in the range. It's at y equals negative 9. It's right down here. And the maximum value of our graph is no max because it goes to infinity. The y-intercepts of our graph are back at 1, 2, let's see, sorry, 1, looks like just there's this one y-intercept at 0, 1. And then for the x-intercepts, do you see both of them? At negative 1, 2, 3, 4, 0. And at 2, 0, there's an x-intercept. And this one's kind of sneaky. Do you see how it's actually going to cross the x-axis too? Up 2 over 1, up. No, it's not even using the same slope. Let's see if we can count this. I don't even think we can get that x-intercept and tell where that's out. But if I had to guess, if you wrote 9, 0, I would take it. But I can't even tell where that other intercept is going to be if we continued that line. The slope's kind of crazy. Okay, all of that was Math 1 features of functions. Now we're going to go do the piecewise function, which is what we've been doing in Math 2. So we start with f of x equals, and you're going to be doing 3 pieces. So let's make a nice big bracket. The first piece is something quadratic. Do you see the parabola? The second piece is linear, and the final piece is linear. Also, we notice that this piece in the middle is going to be a negative slope, and the piece on the bottom is going to be a positive slope. We're going to do the domains off to the right when we're done. So I need the vertex and a critical point for each of these. So I'm going to go over and label on the graph. Here, this is at back 1, 2, 3, 4. So at negative 4, 0 is my vertex. And the stretch is just out 1, up 2. So I'm going to go plug that into my parabola. X minus a negative 4 becomes x plus 4 squared. And then plus 0 is not necessary. Stretch of 2 goes out front. My parabola equation is done. Next is our linear. It's a down 1 over 2, down 1 over 2. That's your slope of negative 1/2. And then critical point, what do you want to use? 2, 0, 0, 1, or negative 2, 2. I'm going to use x minus a negative 2 plus 2, but you can use any of those critical points. Finally, I'm going to use 1, 2, 3, down 9. So x minus 3 minus 9. And then the slope here is up 2 over 1. Oh, that slope is terrible. That's sort of a mess up one. I'm just going to call it a slope of 2, but on the test, it's never going to be ambiguous like that. You're going to be able to tell. Do you guys want to call that up 5 over 3? That makes more sense. Let's do up 5 over 3. Okay, you've got the full equations for your parabola, for your linear, We now just need the domains. So the first piece goes from negative 5 open to negative 2. And I think it's closed. I got to look under my, closed. The next piece goes from negative 2 to 2. And it goes from open to closed. And the last piece goes from 3 to infinity, closed to open. Remember that we've now learned on delta math how to write this as a simpler domain. You could just say x values greater than or equal to 3. That simpler domain is acceptable as well. But in the format of the others, I'm going to write from 3 to infinity. All right, your piecewise function is done. This is what is going to be on the quest. We're going to have one graph where, given the picture of the graph, you're going to have to write the piecewise function. Pause the video, try the next one on your own. It's 3 linear pieces. All right, I'm going to go down and do the math 2 piecewise function first. Let's see how you did. Notice here we've got a slope going down 2 over 1. And then let's use the critical point of negative 1, 2, 3, 4 down 2. That's going to be a linear first piece. The second piece is constant through 3. It's a nice easy one. And then the last piece is a negative slope as well. So this is negative 2x minus negative 4 minus 2. This one's going to be negative 1, 2, x minus 2 plus 6. All right, the functions are done. They're all linear, so there's not going to be any powers of 2. Let's go do the domain. First piece goes from negative infinity to negative 1, 2, 3, 4. Notice the negative 4 has a closed dot, so we want the closed bar there. The next one goes open to open from negative 1, 2, 3, 4 to 2. Notice it's open dot, so leave that without bars. Finally, it goes from 2 to infinity. Notice it's a closed dot here, inclusive, so we're going to include the 2 right there with that bar. So how are you doing on these piecewise functions? Are you getting better with practice? Now I'm going to go do the overall domain range, increasing, decreasing intervals. This is back to math 1. Sorry about that typo there. So I'm going to go over and do the x-intercepts first. I see one at 1, 2, 3, 4, 5, negative 5, 0. And then what about this guy? Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay, so that means that there's going to be 1 there as well. 8, 0. All right, what about y-intercepts? I see one at 0, 3. Are you okay with that? Minimum of the graph, lowest point of the graph. Do you see this arrow to infinity? This arrow to infinity is going to be lower than this dot here. So we're actually going to say that there is no minimum because it goes down forever. Maximum is the same thing. This arrow keeps going forever. So there is no max. Decreasing interval, where is your graph going down? Now this throws students off because this arrow is increasing to infinity, but I'm still going downward on the slope. That confuses some students. So our decreasing interval is going to be from negative infinity to negative 1, 2, 3, 4. Remember, we use all open brackets for increasing and decreasing. And we also say from 2 to infinity, there's that other segment that is decreasing as well. Increasing intervals are none. Interval constant, it's not mentioned here, but the interval that's constant, there is one section that goes from negative 4 to 2. If that's ever asked, you could say, oh, the interval constant is negative 4, 2. Range of this graph goes forever down to forever up, even though there's other stuff going on in between. So we're going to say that the range is from negative infinity to infinity. That's always going to be open, open. Domain of this graph goes forever left, forever right. And even though this stops here, it starts right up there, stops here, but starts right up there. So we can say it's a continuous domain that stops and starts at those same locations. So our domain also goes from negative infinity to infinity overall over the whole graph. All right, you're all done. Great job.